Hey, how are we doing everyone? Welcome to the Bearded Medic. In this video we're going to go through how long-term memory to a pathogen is developed, looking at both T and B cells. Memory to a pathogen is needed, so if we have the same pathogen infecting in the future, we don't have to go through the whole innate and adaptive response again. This saves time as the immune system is primed and the response is more potent and efficient. Both T and B cells that were involved in the primary response to a pathogen, primary being the innate and adaptive response, can develop into T and B memory cells. Let's have a look for T cells first. Most differentiated T cells will undergo apoptosis after the infection has been cleared. Those that remain will develop into memory T cells, and this is determined by the expression of the IL-7 receptor. Now they can either develop into effector memory T cells or central memory T cells. The production of central memory T cells is dictated by the fact that they express the homing receptors CCR7 and L-selectin. And as we've previously mentioned, CCR7 allows cells to home into the lymph node where the chemokines CCL19 and 21 are expressed at high levels. Hence central memory T cells reside in the lymph node. They're essentially like naive T cells because they need antigen to be presented to them again to be activated and can develop into any T helper subtype that's needed. Effector memory T cells are produced when T cells do not express CCR7 or L-selectin, meaning they cannot travel to the lymph node. They instead express other molecules like CCR3 and 5. Effector memory T cells circulate around the body, ready to immediately react to a pathogen. However, unlike their central memory T cell counterparts, they can only turn into Th1 or Th2 subtypes. So, central memory T cells express lymph node homing receptors, hence they reside in the lymph node. Effector memory T cells lack these lymph node homing receptors, hence reside in the periphery in circulation. But what about memory B cells? As we've mentioned previously, when B cells mature, they develop into memory B cells or long-lived plasma cells. Memory B cells are primed to release whatever antibody they were initially activated to release. They are found in circulation in areas that are likely to encounter pathogens, like Peyer's patches. This is because to release these antibodies, memory B cells need to be re-stimulated by the pathogen. This means more specific and therefore more effective antibodies can be released quicker upon reinfection. Memory B cells also have upregulated expression of MHC and the B7 co-stimulatory protein. Why? Because this means that antigen presentation and activation of T cells is a much faster process. Long-lived plasma B cells will migrate to the bone marrow to exert their action. Here, they will release antibodies without necessarily encountering the pathogen. So in the event of reinfection, there are already antibodies ready to neutralize and negate the pathogen's actions. So that's how memory cells are produced. To review, as you can tell, after initial or primary infection, the immune system develops memory in the form of T and B memory cells. Most T cells undergo apoptosis after they have exerted their action in the primary response, but those that express the IL-7 receptor survive. Those that express CCR7 and L-selectin can home into the lymph node where they will reside, able to turn into any T helper subtype. Those that don't express CCR7 and instead express CCR3 and 5 can't go to the lymph node, hence stay in circulation and can only turn into Th1 or Th2 cells upon reinfection. B cells develop into memory or long-lived plasma cells. Memory B cells circulate and need to come into contact with pathogen to release their high-affinity antibodies. Long-lived plasma cells go to the bone marrow to release their antibodies into circulation, so if the same pathogen reinfects, the pathogen is cleared quicker. Clearly this means the secondary response to a pathogen eliminates the need for another innate and adaptive process, as there are already many antibodies in circulation. So this marks the end of the video. Thank you for watching. Leave a like if it was helpful and make sure you leave any questions in the comments to be answered, and try out the quiz on Instagram. See you in the next video. Goodbye.